Welcome, Hornets, and thank you for joining me today. Today we're going to be discussing a radian. What is a radian? And what I'd like to do is I'd like to just take a look at a circle. And this circle, we're going to say, has a radius of length 1. Now, that means that if I have a radius of length 1, and I start right here, so let's kind of overlap an axis onto this. And so this would be my equivalent of an x-axis, and this is my equivalent of a y-axis. So if I have a radius of 1 and I'm trying to go from here all the way around, that means that I'm talking about the circumference. And we all know what the circumference formula is. Circumference equals, that's right, 2 pi r. 2 pi r. Now, if my radius is a length of 1, then that means that the entire circumference has a length of 2 pi. The circumference, arc length of 2 pi. Now, that means that if I go halfway, I have pi times r, right? Notice that this would be 2 pi times r is right here, pi times r is right here. Well, if I want 1/4 of 2 pi, notice I just did 1/2 of 2 pi, and I got pi. If I do 1/4 of pi, I get pi over 2, and that's now up here. So what you'll notice is I am finding the length of my circumference when the radius is 1. Well, that's ultimately what radians are. How many lengths of the radius go around the circle? So if I'm looking at 1.5, this is about 1.5. I'm looking at 1, 2, 3, and this last little bit is 1, 4, 1, 5, etc., because that's what pi is. Okay? So notice the circumference is divided up into lengths of radians, and the length of our radius going around the outer edge of the circle, the circumference, is what we call 1 radian. So that means that if I am talking about radians, this has to be pi over 2 radians, or pi over 2 times my radius. This becomes pi radians, which would be pi times the length of my radius. And I can then look at my unit, this circle, and I can start breaking it up. For example, if I have 1/4 is pi over 2, then 1/8 is pi over 4. And that would be somewhere around here. Well, that means that I can divide my circle into thirds and sixths and twelfths, right? So if I take 2 pi and I multiply by 1/12, I get pi over 6. And pi over 6 is right about here. And if I take pi over 2 pi and I multiply by 1/6, I get pi over 3. And that's about right here. And this is how we find radians. We take our arc in this case, 2 pi r, and we divide by r. Now that means that this is my total arc length. Arc length divided by r is what we call a radian. Okay? And it is the length going around the outer edge of the circle, called our circumference, and that length is a radian. So how much of our circumference are we covering? Okay, that length is called a radian. Alrighty, I hope that made sense to you. as we are going to be using radians in AP Calculus next year, and we'll be using radians throughout this year. Now, please be aware that when we are talking about circles, we have things called rotations. So if I start right here, this is called my initial ray. Initial ray. And then where I end is called my terminal ray. And the length in between is what we call theta. Now, there are 4 quadrants that we work with when we're talking about trigonometry. We have quadrant 1, we have quadrant 2, we have quadrant 3, and we have quadrant 4. Now, be aware that the angle made by wherever we stop our curve, so we take our ray, our initial ray, and we go around the units of this circle, and where we end is called our rotational length. So let's say I start here at my initial at 0 pi, and I'm going to go through 2 rotations. I'm going to look at it as 2 times 2 pi, and that would give me a total of 4 pi radians. So notice, when I'm talking about rotations, I multiply the number of rotations times what is 1 full rotation. In this case, a circumference of 2 pi. If I wanted 5 rotations, or let's do 5.5 rotations, I would take 5 times 2 pi and add to it 1/2 times 2 pi. That would give me 10 pi plus 1 pi for a total of 11 pi radians. Okay? Now you'll notice that we now have this issue of our radians, but in all reality, we do have to still deal with degrees. So let's make sure that we can work with degrees. So if I want to convert, we're going to talk about a conversion now. Conversion. And we want to go from radians to degrees. In order to do this, we have to set up a proportion. The amount of radians that we know over 2 pi is equal to the degrees that we know to 360. Now we can use any equivalent ratio. For example, I could do x radians over pi is equal to y degrees over 180. Or perhaps I want to do x over pi over 4, and I'm going to go y divided by 45 degrees. So it's entirely up to me what ratio I want to work with. But it is the ratio that will allow me to convert from my radians into degrees. So if I want to convert, for example, let's say pi over 3 over 2 pi into degrees, I'm going to have to take 360, multiply it by pi over 3, and then divide by 2 pi. Now you'll notice the pi's will cancel, and I'm looking at 120 over 2, which gives me 60 degrees. And this is now my y degrees. Now if I want to convert from degrees to radians, I use the same basic concept. I choose a ratio of equivalent values or measures. I then put my degrees in, and I then solve for radians. Let's go ahead and convert, 75 degrees into radians. So I'm looking at x is equal to 2 pi, so we're going to have it in terms of pi. We're going to have 150, 2 times 75, divided by 360, and then we reduce. So we can get rid of those and divide. We get 5, and this is going to divide by 3, and we get 12ths pi. My answer is x equals 5 pi over 12 radians. And this is how we convert back and forth between radians and degrees. We use these ratios in order to do that. Okay? So going from radians to degrees or degrees to radians. One other thing that we are often asked to do is find out how many degrees do I cover in a certain amount. So let's go ahead and convert radians to degrees again. But this time, we're going to get even more precise because we have what are called degrees, minutes, and seconds. And be aware that degrees, minutes, and seconds comes from a concept called horology, or the study of time. So just like time breaks down into hours, minutes, seconds, our units, this circle in degrees is going to break down into degrees, minutes, and seconds. So let's convert 1.4562 into degrees, minutes, and seconds. We're going to start off by setting up our ratio. Once again, you get to choose what ratio you want, and I'm going to cross multiply and divide by 2 pi. So I'm going to take 1.4562, I'm going to multiply by 360, and I'm going to divide by 2 pi. Now remember to put parentheses around the 2 pi, or the order of operations will end up multiplying. So you end up hitting enter, and you should get 83.43411,413. So that means that I'm currently looking at 83 degrees, but I have a portion which is 0.43411,413, and I have a portion of 60 minutes. So what I need to do is I need to set this up so that I find out how much of 60 minutes is it. Of means to multiply. So I'm going to multiply this by 60. I'm going to take away the 83, and I'm multiplying by 60, and I'm going to get 26. And then this is my minutes, and our symbol for minutes is 1 tick mark. And I have this 0.04684762 of 1 minute. So I have this portion, and this is of now 60 seconds. So of means to multiply, so I take away the 26, and I'm now only looking at that large decimal, which I now multiply by 60. And I get 2.81. That means that I have 83 degrees, 26 minutes, and 2.8108 seconds. Tack, tack. And this is my conversion. Now, how would I convert backward? Well, I kind of have to remind myself that I was adding, but in this one I multiplied by 60 twice, so I have to divide by 60 squared, and this one I divided by 60 once. So I'm now going to add all of that together, and I'm going to go 83 plus 26 divided by 60 plus 2.8108. Keep in mind, the more decimals you use, the better your answer is going to be. And I'm dividing this by 60 squared. Now, when I hit enter, I should see my 83 again. And once I've got it into the 83, I now convert it back into the radian. So I'm going to have to take this, and I'm going to be multiplying my degrees by 2 pi. And I'm going to be dividing by 360. And you'll notice I go right back to 1.4562, which is what we started off at. So let's just repeat our process. Sometimes we're asked to find more minute values of degrees. Those minute values are minutes and seconds, just like time, with a clock in hours, minutes, and seconds. Similarly, we are going to be having to take our degrees, and when we break our degrees off from our conversion, we're going to end up multiplying by 60 to get minutes, and then we take that decimal and we multiply it by 60 in order to get our seconds. To work backward, we have to take the seconds and divide by 60 squared, our minutes divide by 60 to the first, and then add all three up. And you should put it into your calculator only once and hit enter. Alrighty, so this is how we find rotations. This is how we find degrees. This is how we find radians. This is how we find radians in degrees and so forth. How many rotations and multiplying. This is what a radian is. A radian is simply the length of the outer edge of the circle of a length of one radius in length, whatever the radius of the circle is. So that means that every single circle will have 2 pi radians, or 2 pi lengths of the radius, as we go around the outer edge of the circle. We can then break it up into half a circle, quarter of a circle, eighth of a circle, all the way down, and keep breaking it down. We can also divide into a sixth or a 12th or a third of a circle and break it down further as well. Alrighty, Hornets, that's some of our notes that we started with today, dealing with what is a radian measure, how do we convert radians into degrees, how do we convert degrees into radians, and how do we convert radians into degrees, minutes, and seconds. Thank you very much, and I hope this helped. If you liked it, please click like, and I hope you have subscribed. Thank you very much. Be well and take care. Cheers.